All right, Algebra 1 students, I appreciate you guys coming back for more. You must have enjoyed the first video so much that you could not wait to dive into video number 2. So video number 1 in our first lesson really covered data displays and what they can do for us, what they can show us, what they cannot show us, how we can read them, and some things that we can learn from them, and how we can take those things we learn from them and make inferences and predictions in the future with them. We're going to continue looking and studying data. This lesson here is going to focus more on comparing data. So you might have two different sets, and can we make a claim about one or the other? Can I say that this data is higher than this other set of data? Can I say that this one has a bigger range than this other one? Can I say that this other one has a lower center than the other one? And in order to compare data, you really have to make sure that you have two sets, right? Like if I'm going to compare your score from my score, I need to have two scores, right? If I'm going to compare your shoes to my shoes, I need to have two. If I'm ever going to compare something, I need at least two of them. So everything we look at today is going to be in at least a group of two. Our essential question here that you see at the top is going to ask us, how can we use the center and the spread to compare data sets? Okay, so the center, obviously, you something's in your mind when you hear center. If I'm going to look towards the middle of the data set, how can I compare two data sets with that? And then if I say the spread, right, like how far apart, you have something coming in your mind with that as well. So this first one, we're going to hop in. You had an opportunity to look at this situation here on the right. And this situation here on the right was that you're an artist and you want to sell a piece of your art, and you're choosing between these two galleries, and these are the sales that they've had over the last couple of weeks. So we have Gallery 1, which has had a total of 6 sales, and those sale prices are listed below. And then we had Gallery 2, and they've had 5 sales, and those prices are listed there as well. So before we really get into the data, just hearing what I've just said, there could be somebody who, without even looking closely at those numbers, could say, well, Gallery 1's a better option. They've sold 6 paintings, and Gallery 2's only sold 5, so I might have a better chance of selling one at Gallery 1. Definitely logic that I understand and logic that makes sense, but I think a deeper dive is necessary to really figure out which of these is the better option, assuming that our goal is going to be to make more money. So in order to compare the center, right, comparing the center of data, we really have two choices, right? Should we be using the mean or the median, right? Both of those things help us create a center for our data, but we need to know which one is more appropriate to use and in which circumstance. So the first thing I want to do is I want to find those numbers for Gallery 1 and Gallery 2, and then we're going to take a deep dive into which one makes the most sense here, okay? So if Gallery 1, right here, I want us to find the mean, right? The mean is like another word for average. We need to add all of those up, and then we need to divide it by how many paintings were sold. Well, if I take these 6 prices here and I add them up total, and then I divide them by 6, I'm going to find out that the mean is $3,133.33 is the mean, okay? Now the median is when I line them up from left to right, from smallest to biggest, and I cross out the smallest and biggest pair until I get to the middle, right? If I do that, I'm going to have the numbers 750 and 800 in the middle. There's 2 numbers left, right? I get rid of 500, I get rid of 1500, I get rid of 500, I get rid of 1200, and then I'm left with these 2 in the middle, right? So what I have to do with those is I have to add those and divide by 2. Well, if I add those and I divide by 2, I'm going to get 1550, and when I divide that by 2, my median is going to be $775, okay? So those are 2 different measures, mean and median, and they're significantly different numbers, right? The mean there is much greater than the median. But we can't really do what we're doing until we've studied all of this, okay? So we need to look at Gallery 2 because what we're trying to figure out is which one of those is better for us if we're trying to make the most money. So let's look at Gallery 2. If I go to Gallery 2, okay, let's go ahead and rock a blue here. I want to figure out what's the mean there. So again, now I'm adding up these 5 paintings and dividing it by 5 because there's only 5 sold. And when I do that, my mean or my average is $3,030, okay? And then my median, when I line them up from least to greatest, well, my smallest one is 2750, my largest is 3500, my next smallest is 2800, and then my next biggest is 3100. So my median is actually 3000. Okay, so something else there to consider is that we have those numbers. So we are trying to decide which of these two galleries is best for us. Well, just look at the mean first, right? Or our average, right? So I could say something like this. Well, the average of a gallery painting from gallery 1 is $3,133.33. And the average of a painting in gallery 2 is $3,030 when a painting is sold. Very, very close numbers. They're about $100 apart. If our goal is to make money, then we're thinking right off the bat, okay, well, gallery 1's is a little bit more. They're very close. It's a little bit more. So maybe we're leaning gallery 1. But let's pay attention to these two numbers, right? Because they have something to say about this conversation. So we're going to go ahead and look right here at these two, the median, right? If I'm going to ignore the means here, and I'm just talking about the median, and I say, well, the most middle-priced painting at Gallery 1 sold for $775, and the most middle-priced painting at Gallery 2 sold for $3,000, well, that's a no-brainer. There's no decision there, right? We're going to go ahead and sell our painting at Gallery 2. Well, why is that? Why was the average or the mean so close on these two galleries, but the median was so far apart, right? Some things to consider. So let's go ahead and look over here to the right and mathematically see if we're on the same page here. Are you thinking something that we're going to discuss right here on why those were so different, the mean and median? And they gave us a close answer and then a very far, very kind of straightforward answer. Well, look at gallery number 1, right? We have these paintings. Their prices are $500, $750, $800, $550, $1,200. And then we have this guy, right? This $15,000, right? Must have been a darn good work of art, or it must have been a customer who came in and just was dying to have that piece of art. Is that typical that the prices of those paintings are being sold for around $15,000? No, not whatsoever. We have 4 paintings that went for under $1,000, and we have another painting that was just above $1,000, right? So if you're looking at that, you're thinking, there's a good chance that my painting is going to be right around $1,000 or less if I'm selling at Gallery 1. That's what you should be banking on. You probably aren't banking on being like one of these works of art here for $15,000. What do we call that $15,000, right? That artwork that sold for $15,000. We call that an outlier, right? Something you heard in middle school, something you heard in our last lesson, and it's coming back. Well, what did that outlier do? That outlier wasn't all that present in the median, but it absolutely brought the mean up, right? If I'm going to add all of those numbers up and then divide by 6, we included the $15,000 painting. That's really bringing our mean, it's skyrocketing our mean, and it's really making that data look like it's something that it's not. If I'm going to show you this right here, and you're the artist, and I say, hey, Gallery 1, this is what your paintings sell for, your first observation should be, there's a lot of paintings going between $500 and $1,000 or so, and then, again, somebody got lucky, somebody was a great artist, somebody was right place, right time. I'm really banking on my price being one of these 5 prices or generally around there. So although we have to include this in the data, we cannot just ignore it. We have to recognize it and include it as an outlier and keep that in consideration, okay? Now, there was no outlier here. We have 2,750, 2,800, 3,000, 3,100, 3,500. We're really noticing like this $3,000 trend, right? Our stuff is really close to 3,000 or a little bit above or a little bit below. So then you're thinking, well, if I'm going to sell something at this gallery, there's a good chance I sell it for something around 3,000, right? It's going to go maybe a little bit above or a little bit below. We have no crazy low prices like these hundreds, and we have no crazy high price like this 1,500. This seems like a much more safe bet. So when I go back over here and I'm looking at which of these makes the most sense for me between these 4 numbers, should I use one of these two or should I use one of these two? When there's an outlier like we have, I'm going to start at huge. We have an outlier. We do not want to use the mean. We don't want to use the average when we make that decision. That outlier is drastically changing our average. What an outlier doesn't do is it doesn't drastically change our mean. This is a very representative number of what paintings are being sold for in Gallery 1, and this is a very representative number of what paintings are being sold for in Gallery 2. With that conversation in mind, it seems like a no-brainer, right? We're thinking Gallery 2 is our best option. I'm going to put a smiley face there. We know because of the mean and because we don't want to use, the mean we don't want to use when there's an outlier. We're wanting to use this median number. It's a much more safe bet. If I lined all my paintings up from least to greatest price and found the middle one, this is a price we enjoy much, much more than this if we're the seller, okay? So where are we going with that? What I really have just discussed with you is that when we compare these data sets, we want to pick the one measure that most accurately reflects the data from each set. So our choice is the mean or the median. And we just figured out that the mean is a terrible idea. We do not do it when an outlier is present, okay? When an outlier is present, this is our guy. When there is no outlier, let's go ahead and use the mean, the average, because there's nothing that's pulling our average way up or our average way down in some of these situations. So this is kind of our general rule of thumb, and I'm going to give it a nice pink star there. This is something absolutely to know, to remember, and to use in some of your practice here and even beyond. If you find yourself in a situation like this, you might not be a painter looking for galleries, but there's going to be a time where you want to try to make a decision based on what really, really, actually, truly represents our data in a decision. So this is kind of our general rule of thumb, and we're going to go ahead and say this. We're going to say that when one of the data sets has an outlier, you want to use the median to compare the measure of center, okay? Say that sentence with me. When one of the data sets does have an outlier, you want to use the median to compare your measure. So if I'm going back to that problem, we had an outlier. I just want to make sure these are the numbers that I'm using, my median, to really compare my two data sets and make my decision, okay? Those numbers are much more reflective of all the data combined. All right, so then what does that mean when there is no outlier? So I have this below. When there is no outlier, you should use the mean or the average to compare the measure of center, okay? So I'm going to kind of write this again here, but what I have for you is that when there is an outlier, we use the median. That makes us happy. That represents the data. There is no outlier messing with our stuff. Or excuse me, there is an outlier messing with our average, so we want to use this. When there is no outlier, we want to use the mean, aka the average. That makes us happy. The averages are much more reflective of that data. You're going to get a chance to try that in a couple of problems, kind of to test that out and see. Hopefully you're seeing it in other problems and situations other than just the gallery there. Something absolutely to keep in mind, and I think is a great way to start this lesson. Okay, that's when I'm, again, comparing the center. Those things tell us about the middle part of the data. The median is the middle part of the data, and the average generally has just as many points above as there are below, okay? Generally, unless there's that outlier, okay? Here we go. So now if I'm going to consider a box plot situation, and I'm going to compare these two, I'm going to read this with you, and we're going to get a chance to see if we can help this student out. So this example right here says, it says, Caitlin claims that the students at her school are raising more money for charity than the students at Phillips School. The amount raised by 30 students at each school are shown below. Does this data support Caitlin's claim? So we have to, when we leave this problem, be able to say, yes, Caitlin's right. Her students at her school are raising more money, or no, she's wrong. Students at Phillips School are the ones raising more money. Okay, so what we see here, you're recognizing from the last lesson here, is we have Caitlin's school represented as a box plot, and we have Phillips School represented as a box plot. Okay, and we need to make some general claims and ideas about this. And at the end, we're going to circle back to, can we answer Caitlin and tell her if she's right or wrong? Well, the first thing that we're seeing here is, let's just start finding some of these pieces of information for Caitlin's school and for Phillips School by looking up above, right? The first thing it says is, what's the minimum? Okay, so we're looking up above. Can I see the minimum? Here's these lovely box plots up above. I see Caitlin's school, the minimum is right here. And it looks like if I count those tick marks, that's at 21, 22, 23, 24, 25. So the student that sold the least amount of money at Caitlin's school sold $25 or raised $25 for charity. And it looks like Phillips School has the same number, right? They're also at that same number. So Phillips School, the student that raised the least amount of money, raised 25. Right now, their schools are looking exactly the same. Let's keep going. The first quartile, right, we know is this space right here. Okay, we're going to look at Caitlin's school. If I look at the tick marks, that looks like it's at 30, 31, 32. So the first quartile is $32 was raised by the first quartile at Caitlin's school. And at Phillips School, it's all the way up here. Okay, which it looks like that's at 41, 42, 43, 44, 45. It's nice that we have those tick marks. Okay, we can't make any claims yet. We need to look at all of this 5-number summary, all of this data. Okay, so we're going to keep going. The median, right, is this one that we have right here. And it looks like that's the same as the one below, right? So Caitlin's median at school is 45. The students, if you line them up from least to greatest, the very middle student raised 45 for charity. And at Phillips School, right, we have, it looks like it's at 50, right? That student in the very middle of all 30 students was at 50, okay? We're going to keep going. We have Caitlin's third quartile right here. And it looks like that number is at 51, 52. We're going to have Phillips School, which is right here. It looks like we're at about 51, 52, 53, 54, 55. Looks like it's about 56 to me. Okay, now let's go ahead and answer these maximums. It looks like they're the same, and it looks like they're both at 68. Okay, so those are the same. We need to start comparing things, right? And again, Caitlin is saying her school, generally, the students raised more money for charity. Let's answer this last question. The IQR, which again is quartile 3 minus quartile 1. So for this one, it would be, let's go ahead and hit it with the red. Let's go with the green. Quartile 3 right here minus quartile 1. So 52 minus 32 is 20. And this other one here is we have 56 minus 45, which is 11. Okay, so now we need to really start comparing some of this data. I'm going to erase these and put the numbers back so they're a little bit prettier. That was 32 and 45. Let's put that back in blue. That was 32 and 45. Oh, that's purple. This is 45. And then I'm going to clear these up a little bit too. That's 52 and 56. 52 and 56. Let's blue that a little bit. 52 and 56. Okay, if I'm just generally looking for who sold more, right? Let's look at the minimum, okay? So I'm going to kind of go through these as a checklist. This minimum, these are exactly the same, 25 and 25, kind of a wash, right? And the minimum is just that student that either was lazy. I don't know if you can call them lazy if you raise $25 for charity. That's a very nice act. We're not going to get on your case there. So just kind of a wash. We're not going to use that. The next one is the first quartile. So that, again, first quartile is like the 25th percent. Right? It looks like Phillips School is significantly higher. I'm going to go ahead and circle that in red. Okay. He's got the student, the 25th percent student is higher for Phillips School. Let's go ahead and look at the median, right? Who's got the higher for the median? Phillips School again. Median again is like the 50th percent. The student smack dab in the middle. We have advantage, Phillips School. Okay. We're going to look over here again. Third quartile, which is like the 75th percentile. Advantage, Phillips School, right? Higher on all three of those counts. We're going to go ahead and go to the maximum, right? Maximum here. I'm going to go ahead and put the X back there in red. Maximum the exact same, just no advantage either school, excuse me. It looks like both of those people had somebody, the highest seller was, or highest raiser was $68. And then we have this spread here, which is the first time that Caitlin's school has a number that's bigger, but we need to understand what that means. What that means is that the difference from the 75th to the 25th percentile student was just a bigger gap, right? These two numbers are a little bit farther apart than these two numbers. So it just means that generally that this data was more compact. This center, right? Center and spread was a little bit more compact than this center and spread, okay? I should maybe just use spread there. This spread is a little bit more compact towards the center than this spread. It doesn't really mean anything as far as who raised more money. It just means that those numbers are closer together. 50% of Phillips School, the students were closer in their fundraising than 50% of the students at Caitlin's school in the fundraising, okay? So now we need to really answer, is Caitlin's claim correct? I want to clear all of this here in this part. because I want us to be able to make a couple additional claims here. I think we're all on the same page here. I'm assuming that Caitlin's claim is not correct, right? Her claim is not correct. We noticed, okay, no, because why, right? No, why? Well, because we noticed that for Philip's school, we noticed he has a higher first quartile, first Q, higher median, and a higher third quartile, right? And then we also know that they had an equal minimum and maximum. Those are the 5-number summary: the first quartile, the median, the third quartile, the minimum and the maximum. Not a single one of those was Caitlin's school higher. So I don't think she can really at all say that her students raise more money, okay? What claims can we make instead? Well, we can almost just go ahead and say all of these things, right? Philip's school had a higher first quartile, had a higher median, had a higher third quartile. Those are absolute claims that we can make. What else can we say? Well, let's look up above. We talked about a huge advantage of these things are these are percentages, right? We talked percentages. I already wrote some over here. Okay, percentages is this, right? I noticed at Caitlin's school, the top 50%, okay, so I'm seeing right here, this is 25%, another 25%, another 25%, and another 25%. So 25 plus 25, 50. This top 50%, so half of the students raised as much as, here's 25 plus 25 plus 25, as 75% of Philip's school. So we're saying that 75% of Philip's school raised just as much money as only 50% of Caitlin's school. That's a big difference. That's 25% apart, right? That speaks volumes for itself. If you think of fractions, 3/4 of Philip's school did what 2/4 of Caitlin's school did. There's a lot more people contributing here. In a span of 30, that's around 7 or 8 extra students raising that amount of money more than some of Caitlin's schools did, right? You could even say something like, if I kind of want to backtrack that and make a claim the opposite direction towards the lower half, I could say something like the bottom 25%, right? This is one whole piece for Philip's school. The lowest 25% of Philip's school raised the same amount of money as the bottom 50% of Caitlin's school. So half of Caitlin's school, 50% of Caitlin's school raised equal to the bottom 25% of Philip's school, meaning it took a lot more students for Caitlin's school to raise the same amount of money for 25% of Philip's school. I think everything is pointing in the direction of Philip's school is the students are pulling a little bit more maybe working a little bit harder on that fundraising there, and so on and so forth. I think that's definitely worth noting there, okay? So comparing those, it's very, very nice and convenient for finding some of those percentages, right? Can I make a claim like that? Can I find a point where we have an equal piece? Now, those are representing two things, right? For Caitlin's school, this is the median because it's right in the middle of her data. For Philip's school, this is the first quartile. But that helps us make those comparisons. We can talk about percentages and make those claims, say 25, 50, 75%, 100%, things like that. Absolutely advantages and things that we're looking for when we compare the center and the spread, okay? Comparing the spread here, I'm going to create a second video that goes along with this. So if you want to take a break and pause and find my video, I'm going to go ahead and pick up on my next video here at this part, comparing the spread using the mean absolute deviation, okay? I think this is a good part to pause, and I will pick up on these notes for you to get you some information on comparing the spread again using mean absolute deviation. We will talk soon. I appreciate you following along in the first two parts of this lesson.